Next point now we go into, and that is about a concept of work. Now what do you mean by the term work, W? Okay, now it's very simple. If I want to ask you, please tell me what is the formula for work, and I guess you will be telling me simple. Work is equal to force into displacement, right? So W is equal to force into displacement, where D stands for displacement, or the distance traveled by the object. And in order to travel that particular distance, some amount of force has to be applied, and that F stands for force. So F is equal to the force applied on the substance, and D is the distance traveled by that particular substance. Now in thermodynamics, normally the work is related to pressure volume. We normally say it's a pressure volume work. Okay, W is equal to pressure volume. This is what it is. Now how we related all these things? Okay, very simple, my dear friends. You know that pressure is equal to force upon area. Yes or no? Yes. Okay, so pressure is equal to force upon area. So therefore, PV, when we talk about, what we have to say is force upon area into V. Now here, let me be very clear. If I talk about D as distance, so when you talk about area, you know its units very well. Okay, it will be square. And when you talk about volume, it's going to be cube. You know it very well, right? So as a result of which, what are we going to get is F upon D square, okay, that is distance square, into D cube. So that is equal to nothing but force into D. D square D cube. So you get D. And see this. Okay, and that is nothing but equal to what? W. You getting it? And therefore, in thermodynamics, we go for W is equal to PV, or we generally represent it as what? Pressure, volume, work. You getting it? Fantastic. Now, my dear friends, I'll explain you this concept of work by giving you two simple examples. Example number one is, and that is, we talk about decomposition of hydrogen peroxide. Hydrogen peroxide, the formula is H2O2. Now, when hydrogen peroxide decomposes, it gives you 2H2O as well as O2. Alright? This is what is the decomposition reaction. Now, we go into the physical state. Hydrogen peroxide is a liquid. Now, it decomposes into water. I haven't said ice or water vapor. I've said what? Water. So, it's very evident it is liquid. And I guess this everybody knows it's a gas. Alright? Now, if you remember, if you consider a cylinder, as I told you before as well, okay, and there is a movable piston, alright, all these things. Now, what will happen is, this reaction results in the formation of a gas. Alright? And the gases are going to be lighter, and therefore they are going to rise. And as a result of this, the piston will be moving upwards. Okay, this is going to prompt the piston to go upwards. ये गैस जो बना है ऑक्सीजन गैस, और इसी वजह से हम क्या बोलेंगे कि पिस्टन ऊपर की डायरेक्शन में गया है. Piston is moving upwards. और क्योंकि पिस्टन इज मूविंग अपवर्ड्स, ये गैस जो बना है सिस्टम में, उसके वजह से पिस्टन ऊपर की तरफ जा रहा है. ये बीकर के बाहर जा रहा है जहां पर रिएक्शन हो रहा है, और बीकर के बाहर जा रहा है दोस्तों, मतलब ये बहुत ही सिंपल है, ये सराउंडिंग में जा रहा है. और इसीलिए हम लोग बोलेंगे यहाँ पे कि देयरफॉर द वर्क इज डन बाय द सिस्टम ऑन द सराउंडिंग. हम ऐसा बोलेंगे इसको, क्या बोलेंगे इसको? डन. ये दो शब्द बहुत इंपॉर्टेंट है दोस्तों, बाय द सिस्टम, ऑन द सराउंडिंग. ओके, और इसीलिए हम इसे पीवी एक्सपांशन के तौर से भी जानते हैं. ओके, व्हाट वी कॉल इट एज? इट्स अ पीवी एक्सपांशन. Okay, so whenever gases expand, the work is done by the system on the surrounding. Alright, so there the piston is going upwards. Clear? Concept is clear? Good. I'll give you a next reaction. The next reaction is all about NH3. It's a gas, everybody knows about this. I'll take HCl also in a form of a gas, and this is going to give me NH4Cl, which is a solid. Now in this reaction, see, this is opposite to the one which I've discussed so far. In this case, the gas was released. यहाँ पे the gas is consumed. Okay, क्योंकि यहाँ पे solid बना है, तो gas इस्तेमाल हो चुका है. Okay, so the gas is consumed, used up. और गैस कंज्यूम होने की वजह से अभी क्या होगा, पिस्टन नीचे की तरफ जाएगा. ओके, द पिस्टन इज गोइंग डाउनवर्ड्स. अब पिस्टन डाउनवर्ड्स कभी जाता है, याद है आप लोगों को मैंने बताया था एक्सटर्नल प्रेशर, इंटरनल प्रेशर. सो पिस्टन नीचे की तरफ कभी जाएगा जब बाहर से प्रेशर ज्यादा होगा, और बाहर से प्रेशर ज्यादा होगा मतलब कहां से होगा, सराउंडिंग से होगा. Okay, and therefore what we say is in this particular case is the work is done on the system by the surrounding, और इसे हम बोलेंगे PV contraction. क्या बोलेंगे हम उसको, PV contraction. अब यहां पर ये दो वर्ड्स चेंज हो गए, इसलिए मैंने यहां पर भी बताया था आपको by and on. ओके, ये चेंजेस आ जाते हैं फिर इस हिसाब से. तो याद रखिएगा दोस्तों, द पॉइंट विच इज टू बी नोटेड इज whenever gases, whenever we talk about, it has got two properties. It undergoes expansion, it can also undergo contraction depending upon the pressure, internal as well as external. जब expansion होता है तो work is done by the system. ये याद रखें. So common sense है, it will be on the surrounding. और जब contraction होता है तो याद रखिएगा work is done on the system. Okay? तो ये दो चीजें दोस्तों याद रखिएगा. Expansion is work is done by the system. Contraction is work is done on the system. Okay, and whatever the word is, accordingly you flip around, so that means you'll be getting for the surrounding. यानी ये इसका मतलब यहाँ पर अगर by the system है तो it will be on the surrounding, और अगर यहाँ पर on the system है तो क्या हो जाएगा, by the surrounding. लेकिन what I am going to consider over here is system, because I made it very clear in the beginning of this chapter that in thermodynamics we are going to consider system, all right, not the surrounding. So that's the reason we have expressed it in this way. Alright, so I guess now the concept of work is very clear to you all, okay, with the help of these two examples, right? My dear friends, we now go into the concept of heat. Heat is being denoted as what? Q. So when you talk about a concept of heat, remember my dear friends, that whenever we talk about a reaction, there are two possibilities. And those two possibilities are either the heat is absorbed or the heat is released. Or simple words, absorb means it is in and release means it is out. In is nothing but it is related to endo, out means it is related to exo, and it is related to heat, and therefore we say it is thermic, and here as well it is thermic. Okay, so a process or a reaction in which the heat is released, that is called as exothermic reaction, and a reaction in which the heat is absorbed, we call it as endothermic reaction. Clear? Concept is all right? Very good. The next one is, and that is we talk about sign conventions of W as well as Q. We talk about sign conventions. Okay, the first one is of W. Now, as I said before, that we talk about work with respect to two concepts, by the system and on the system, right? So, let us start off with that. The first possibility is by the system on the surrounding. When it is going to take place, that is going to during expansion of gas. So, in making the gas expand, the system is giving out energy. And whenever you give out something, so obviously that thing becomes less within yourself. सिंपल है ना ये. अगर आपने कोई भी चीज दे दिया तो देने के बाद वो चीज आपके पास कम हो जाती है. तो वैसे यहां पर भी है, सिस्टम ने अपना एनर्जी का इस्तेमाल किया है. क्यों? गैस को एक्सपांड करने के लिए. ऑलराइट, और इसी वजह से उसकी एनर्जी में कमी आ गई है. कमी आ गई मतलब वो कौन सा साइन आएगा? नेगेटिव साइन आएगा. ओके, क्योंकि हम साइन कन्वेंशंस डिस्कस कर रहे हैं. सो वी नीड टू कंसीडर अंडर विच कंडीशन इट्स गोइंग टू बी पॉजिटिव, इन द विच कंडीशन इट हैज टू बी नेगेटिव. सो W के बारे में हम बात कर रहे हैं. सो बाय द सिस्टम on the surrounding that takes place during expansion of gas, and that is going to be what? Negative. ये याद रखिएगा. ओके, इट्स एज सिंपल एज दैट. अभी जैसे मैंने पहले भी बोला है, केमिस्ट्री की पढ़ाई करने का एक तरीका होता है. एक कंसेप्ट पढ़ो, समझ लो उसको अच्छी तरीके से, और उस हिसाब से दूसरे के लिए घुमाओ. तो दोनों नहीं पढ़ना है. तो यानी एक सिंपल सी बात है कि अगर मैंने आपको पूछा कि पॉजिटिव के लिए क्या होगा, तो ये घुमाओ, ये दोनों वर्ड्स को फ्लिप करो. बाय की जगह ऑन करो, ऑन की जगह बाय करो. ओके, और यहाँ पर एक्सपांशन है तो उसको ऑपोजिट कर दो, तो क्या बन गया? कॉन्ट्रैक्शन. इज एज सिंपल एज दैट. सो whenever we talk about work on the system by the surrounding, तो फिर क्या हो जाएगा? contraction of gas. ओके, और contraction of gas हुआ तो क्या हो जाएगा? वो पॉजिटिव. क्योंकि इस समय क्या हो रहा है? From outside, the external pressure is more. Outside means what I'm talking about? Surrounding. The surrounding is using its energy to compress the gas. Okay? यानी surrounding का energy कम हुआ है. और आप तो जानते हो, you have done it in your lower classes. Energy can neither be created nor being destroyed, but it can be converted from one form to another. याद है ना दोस्तों? जी हाँ. तो यहाँ पर in the universe is made up of what? The formula I have already given you. System as well as surrounding. तो अगर एक का एनर्जी कम होता है तो दूसरे का एनर्जी बढ़ना जरूरी है, तभी जाकर एनर्जी बरकरार रहेगा. The energy will remain constant. So in this particular case, for the contraction of the gas, the surrounding has to use its energy. So the energy of the surrounding goes down. And if I want to keep the energy constant, the energy of the system should rise. Rise मतलब increase, और increase मतलब क्या? Positive. ऐसे याद रखो दोस्तों, बहुत आसान हो जाएगा. और अगर आसान हो गया तो आपको अच्छा लगने लगेगा. प्यार तो करना ही है, केमिस्ट्री से आपके पास कोई ऑप्शन नहीं है. Alright, so ये क्लियर हो गया आप लोग को. This is sign convention with respect to what? Work. अब जाएंगे हीट के बारे में. मैंने आपको ऑलरेडी बता दिया है कि reactions are of two categories, exothermic as well as endothermic. Once again, simple part is it's absorbed is in. कोई भी चीज अगर आप लेते हो, ओके, तो वो बढ़ जाएगा. ओके, देने से कम होता है और लेने से बढ़ता है. ओके, सिंपल रूल है दोस्तों. और इस वजह से what are we going to say is in a endothermic process the Q is going to be positive. Okay, and in a exothermic process the Q energy is released out. कम हो जाएगा. कम हो जाएगा मतलब क्या हो जाएगा? वो नेगेटिव हो जाएगा. Understood this? So these are the cases that you need to understand. Under which possibilities are going to be positive, negative. So just a brief recap. Okay, and that is when you talk about work by the system on the surrounding, so it has to be negative. Okay, expansion of gas on the system by the surrounding, it has to be positive. Contraction of gas. Okay, come to Q, heat, endothermic reaction. Okay, energy increases, so it's positive. Exothermic reaction, energy decreases, and therefore Q is negative. Okay, and this is what you have in front of it. Am I very clear with this? It's absolutely going into your head, and fix it. Make sure it doesn't go out of it under any circumstances. Am I right? Yes. Next is, my dear friends, we go into the derivations. So let us start with the derivation of work. It's very simple. Okay, don't worry. Okay, derivation सुन के, oh my God, ये तो बहुत डरावना है. ऐसा बिल्कुल भी नहीं है. ओके एकदम क्लियर फ्रेम ऑफ माइंड रखिएगा, सब कुछ इजी है, ऐसा सोच के चालू करो, देखो आपको वाकई में इजी लगेगा. ओके सो वी स्टार्ट विद द डेरिवेशंस एंड दैट इज द फर्स्ट वन इज विद रिस्पेक्ट टू वर्क. अब इन दिस केस व्हेन यू टॉक अबाउट डेरिवेशन विद रिस्पेक्ट टू वर्क, द कंडीशन दैट वी आर गोइंग टू कंसीडर इज आइसोथर्मल इरिवर्सिबल प्रोसेस. ओके कौन सा कंडीशन है? आइसोथर्मल इरिवर्सिबल. इरिवर्सिबल मींस वन डायरेक्शन. रिवर्सिबल पढ़ाया था ना मैंने आपको, इट्स टू डायरेक्शंस, फॉरवर्ड एज वेल एज बैकवर्ड. इरिवर्सिबल ओनली वन डायरेक्शन, दैट इज फॉरवर्ड. Now to make this concept much more easier, what we'll do is same example once again, and that is we are going to consider a cylinder. We are going to fill up with a gas. Okay, we take 1 mole of a gas. We are going to fit it up with a piston which is movable, and why it is movable I've already mentioned it, because it is weightless as well as frictionless. ठीक है, this is what it is. Okay, so when it about work, yeah, आपको फॉर्मूला मालूम है, work is equal to force into displacement. Okay, so let us consider expansion of 1 mole of a gas. क्या कंसिडर करेंगे? एक्सपांशन ऑफ 1 मोल ऑफ गैस. अब जब एक्सपांशन होगा दोस्तों, सो इट इज वेरी क्लियर. अभी मैंने बताया था आपको कि द पिस्टन विल बी लिफ्टेड अपवर्ड्स. ओके एंड द पर्टिकुलर डिस्टेंस व्हिच इज बीइंग ट्रैवल्ड लेट अस कंसीडर एज d. सो d इज द डिस्टेंस ट्रैवल्ड by the piston in the upward direction. All right. F is nothing but the force, okay, which is being applied onto the piston. So work is equal to force into displacement. Clear हो गया यहाँ तक? Next thing is, आपको ये भी अच्छी तरह से मालूम है that pressure is equal to force upon area, and therefore force will be equal to pressure into area. ठीक है? Let us consider this as equation 1. Let us consider this as equation 2. So now, substitute equation 2 in equation 1. Alright? And see what you get. Okay, that is W is equal to, instead of F, you are going to write down what? Pressure into area into distance. Yeah, displacement. Okay, now this D is nothing but the distance traveled by the piston, and this A is standing for area. A stands for what? The area of the cross section of this particular cylinder. ये inside area जो है वो. Okay, now please be very careful that this area into displacement, yeah, into the distance, the product of this is nothing but bringing about the change in the volume of the gas. इससे क्या होगा? वॉल्यूम ऑफ द गैस में चेंजेस आएगा, और चेंज को हमेशा हम लोग क्या रिप्रेजेंट करते हैं? डेल्टा. सो डेल्टा V इज इक्वल टू एरिया इनटू डिस्प्लेसमेंट. और अगर ये यहां पर सब्स्टिट्यूट कर दिया जाए, सो व्हाट वी गेट इज देयरफॉर W इज इक्वल टू P. Okay, this is nothing but the external pressure which I am talking about. A into D is delta V, so we have delta V. So W is equal to P delta V. ऐसा लिखेंगे हम लोग. अब क्योंकि यहां पर देखिए एक्सपांशन कंसीडर किया है, and I've been explaining you sign conventions. So in sign conventions I made it very clear, whenever there is an expansion, work done is always negative. So यहां पर आएगा ये negative. So W is equal to minus of P delta V. Okay, this is what the expression that we get. समझा आप लोग को? Derivation के सारे पॉइंट समझ में आए? Once again, W is the verb, F is the force acting on the piston, and D is nothing but the distance traveled by the piston. हम कंसीडर करेंगे क्या? Expansion of 1 mole of a gas. तो उसके वजह से पिस्टन क्या होगा, विल बी लिफ्टेड अपवर्ड्स. D is nothing but, जैसे मैंने बोला है, distance traveled by the piston in the upward direction. So pressure is equal to force upon area, आप जानते हो. So force is equal to pressure into area. Alright? So substitute करो इसको second को in one, so we get pressure into area into displacement, या distance. Product of the area into displacement brings about changes in the volume. So delta V is equal to A into D. And therefore, if we substitute this, we get W is equal to pressure into delta V. और ये negative sign क्यों आया है? Because we are considering what? Expansion of the gas. Okay? कुछ difficulty लगा derivation में? नहीं ना? That's it. Okay? Step by step समझने की कोशिश करो. अपने आप समझ में आ जाएगा आपको. Alright? Now next thing is कि sign conventions with respect to the expansion contraction की बात करता हूं मैं. So as a result of which, जब हम expansion की बात करते हैं, when we talk about expansion, okay, W is equal to minus of P external V2 minus V1. जानते हो ना ये आप? State function. Okay, delta V. Delta मतलब difference, and difference is always going to be final minus initial. So final volume and the initial volume. Now whenever the gas expands, तो initially वो इधर है, final में इधर है, तो आप जानते हो कि final volume बड़ा है initial volume से. Alright? तो expansion के दौरान the final volume is greater than the initial volume, and therefore we say V2 minus of V1 is equal to positive. Okay, ये पूरा पॉजिटिव होगा, पॉजिटिव इंटू नेगेटिव इज नेगेटिव, एंड देयरफॉर W इज नेगेटिव. और यही मैंने आपको पहले भी बताया था. ड्यूरिंग एक्सपांशन ऑफ गैस द वर्क डन इज नेगेटिव. ओके, सिमिलरली जब हम कॉन्ट्रैक्शन की बात करते हैं दोस्तों, व्हेन यू टॉक अबाउट व्हाट कॉन्ट्रैक्शन, तो इनिशियली समझो गैस का वॉल्यूम इधर है, अब उसका कॉन्ट्रैक्शन हुआ तो वो नीचे की तरफ चला जाएगा. तो इनिशियल वॉल्यूम बड़ा है और फाइनल वॉल्यूम छोटा है. सो इन कॉन्ट्रैक्शन व्हाट वी आर गोइंग टू से इज V2 is less than V1, and therefore V2 minus of V1 is negative. Lower minus of higher value always gives you negative. और ये नेगेटिव हो गया, ये नेगेटिव ऑलरेडी है, तो नेगेटिव नेगेटिव becomes what? Positive. So therefore W is positive. आई बात समझ में दोस्तों? Okay, so during contraction W is positive, and during expansion the W is negative. This is what we conclude, and this is what the entire derivation is for work done during an isothermal irreversible process. You understood everyone? Great. My dear friends, we now move into the next part, and that is about how to consider the expression of work during free expansion. So the title is Work During Free Expansion of Gas. Now my dear friends, it's very simple. Whenever we talk about free expansion, okay, that means we are generally talking about vacuum. And we talk about pressure is equal to zero. The opposing pressure, okay, is equal to zero. Now if you remember, I have already derived that W is equal to the opposing pressure, okay, delta V, and there was a negative sign. Do you recollect this? Yes. Now if you can just substitute this particular expression into this, what we get simple is W is equal to 0. And hence the most important statement is, therefore when there is no opposing force, no opposing pressure, no work is done. This is a very simple and yet the most important statement. So when there is no opposing pressure, that means external pressure is equal to 0, alright, no work is done, and therefore during free expansion no work is done. Am I very clear with this? As simple as that? Yes. Now let us move towards another derivation. Once again, it's related to work, but then this time it is maximum work. So what I feel now is, before I actually go into the derivation, let us first of all try to understand what exactly that concept of maximum work is all about. So here we go. The concept of maximum work. Now for this to be very clear, my dear friends, I would like to go back to that particular expression, and that is W is equal to minus of external pressure delta V, okay, which I've been deriving before as well. Now, as far as this expression is concerned, this is very clear. Forget about the negative sign because that is about sign conventions, which I've already discussed with you all. So ignoring that negative sign, if you just find out the relationship between W and the external pressure, the answer is very simple. The relationship is directly proportional. Alright, so that means if the external pressure is less, the work done is less. Next, in the case of free expansion of gas, I said external pressure is equal to 0, so we said W is equal to 0. So when we say that the external pressure is going to be high, the W is going to be high. And when the external pressure reaches a maximum, we say that the work is maximum. Getting it? Sorted out? So the work done is going to be maximum when the external pressure is going to be maximum. Now let us try to understand that P is going to be the pressure of the gas which is present inside the system, or I'll just call it as internal pressure. Alright? External pressure, you know very well, that is an opposing pressure. So if I want to go for delta P, so delta P I'll just write it down as P internal minus P external. I write it this way. Okay, because this is a driving force and this is opposing force. And always remember, my dear friends, whether the reaction is reversible or irreversible, it always starts from the forward direction. और अगर एक रिएक्शन को आगे की गति में जाना है, आगे की दिशा में जाना है, तो हमेशा ड्राइविंग फोर्स अपोजिंग फोर्स से ज्यादा होना चाहिए. Am I very clear? इसलिए हम लोग ने ऐसा लिखा इंटरनल प्रेशर माइनस एक्सटर्नल प्रेशर. सो देयरफॉर हम क्या बोलेंगे कि एक्सटर्नल प्रेशर विल बी इक्वल टू द इंटरनल प्रेशर माइनस ऑफ डेल्टा पी. हम ऐसा लिखेंगे, ठीक है. अब इसे हम सब्स्टिट्यूट कर देंगे यहां पर इस पर्टिकुलर एक्सप्रेशन में, तो हमें मिलेगा एक और एक्सप्रेशन, दैट इज W इज इक्वल टू माइनस ऑफ एक्सटर्नल प्रेशर की जगह पर अभी ये लिखेंगे हम लोग. सो दैट इज इंटरनल प्रेशर माइनस डेल्टा पी, ओके, इनटू डेल्टा वी. सो इस एक्सप्रेशन से बहुत क्लियर हो जाता है दोस्तों, एंड दैट इज कि W is going to be maximum when delta P is going to be least small. कि जितना वैल्यू ये स्मॉल रहेगा उतना ये वैल्यू ज्यादा हो जाएगा, और जितना ये वैल्यू ज्यादा हो गया उतना W ज्यादा होगा, और W फिर भी मैक्सिमम. So what does delta P stands for? Okay, delta P is nothing but what? It is the difference between the internal pressure and external pressure. यानी ड्राइविंग फोर्स और अपोजिंग फोर्स के बीच का जो फासला है वो डेल्टा पी है, और वो कम होना चाहिए, तब जाकर W मैक्सिमम होगा. और दोस्तों याद कीजिएगा, मैंने आपको रिवर्सिबल प्रोसेस समझाया था, उसमें मैंने यही बोला था इनफाइनाइट सिमिली लेस, ये शब्द का प्रयोग किया था. Okay, the difference between the driving force and the opposing force is infinitesimally less. और वही मुझे यहाँ पर भी बताना है कि therefore the external pressure is infinite similarly less than the internal pressure. Okay, yani opposing force is infinitesimally less than the driving force. Okay, and at that stage we say that the W is what? Maximum. Okay, maximum work is going to be done. Okay, और मैंने ये भी बताया था आपको कि this is during a reversible process. Okay, ये जो condition है ना, that is during what? Reversible process. I also told you one more thing. The reversible process takes a long time because the number of steps are more, and therefore it's a slow process. So maximum work is associated with what? Slow process. Okay, दोस्तों, clear हो रहा है? This is associated with a slow process. This is associated with a reversible process. Okay, that is W max. Okay, this is all about the concept of maximum work. I am very sure you have understood this concept very well. Yes or yes? Yes, my dear friends. Once the concept of maximum work is very clear, now we go for its derivation. So it becomes very easy for you to understand. So we go into the derivation for maximum work. We also call it as W max. Alright? So for that purpose now, try to understand this very well. I go as slow as possible, step by step, so it becomes very clear to everyone. Okay, I'm very confident about it. Okay, so to begin with, as usual, let us consider a cylinder which is fitted with a movable piston, that is a weightless and a frictionless piston. It is filled with 1 mole of a gas, right? Next is, some terms is, F is considered as the constant force acting on the piston. Next one is, A is the area of cross section of the cylinder. Next is, we consider expansion of 1 mole of gas. So the displacement, that means the piston will be moving upwards by a small distance. क्यों स्मॉल डिस्टेंस? क्योंकि कितना डिस्टेंस वो तय करेगा वो किसके ऊपर आधारित है? अमाउंट ऑफ द गैस के ऊपर. अगर अमाउंट ऑफ द गैस ज्यादा है तो पिस्टन ज्यादा डिस्टेंस कवर करेगा ऊपर की तरफ, लेकिन अगर अमाउंट ऑफ द गैस कम है तो ऑब्वियसली वो थोड़ा सा ही डिस्टेंस ट्रैवल करेगा. तो यहां पर भी वही है, इट्स ओनली 1 मोल ऑफ अ गैस. ये देखिए आप, ये दिख रहा है आप लोग को 1 मोल ऑफ गैस, और इसलिए जो डिस्प्लेसमेंट होगा वो भी छोटा होगा, और छोटा होगा इसलिए हम लोग D का इस्तेमाल करते हैं, एंड L stands for that length. Okay, so it's DL means the small amount of the displacement due to the upward movement of the piston because of the expansion of only and only 1 mole of a gas. Concept is very clear? Very good. Now next thing is, we consider about normal expressions of pressure. Now you know very well that is pressure is equal to, yes, force upon area. Okay, you also know that W is equal to force into displacement. F is force and DL is the displacement. But now यहाँ पर F is constant. And if F is constant, so that means W and DL are directly proportional. So अगर displacement is small, so obviously the work also has to be small. So I write it down as dW. समझा आपको? वापस से बोलता हूँ, work is equal to force into displacement. Here in this derivation, we have assumed that the force is constant. So work and displacement are directly proportional. The displacement is small. I already explained you why. So obviously the work done is also small, and that is dW. So dW is equal to force into displacement. Clear हो रहा है? Very good. अब P is equal to F upon A, that is pressure is equal to force upon area. तो इस वजह से हम ऐसा भी बोल सकते हैं, force will be equal to pressure into area. Okay? Force will be equal to pressure into area. अब ये इधर substitute कर दीजिए. तो what we get is dW is equal to pressure into area into dl. ठीक है? ये डिस्टेंस है, ये एरिया है, ये प्रेशर है. अगर डिस्टेंस सेंटीमीटर में है दोस्तों, तो एरिया सेंटीमीटर स्क्वायर में होगा, और सेंटीमीटर स्क्वायर इंटू सेंटीमीटर मतलब क्या हुआ? सेंटीमीटर क्यूब. और दोस्तों सेंटीमीटर क्यूब आप अच्छी तरीके से जानते हो कि इट्स अ यूनिट ऑफ, बोलो यस, मुझे सुनाई दे रहा है यहाँ पर, वॉल्यूम बताना चाहते हो ना? 1 नंबर. ओके, सो व्हाट वी हैव इज दैट वॉल्यूम इज इक्वल टू एरिया इनटू डिस्प्लेसमेंट. लेकिन एरिया देखो यहाँ पे कांस्टेंट है, सो वॉल्यूम एंड डिस्प्लेसमेंट आर डायरेक्टली प्रोपोर्शनल. तो डिस्प्लेसमेंट अगर कम है तो जाहिर सी बात है वॉल्यूम भी कम है, सो dV इज इक्वल टू A इंटू dl. अब ये यहां पर सब्स्टिट्यूट कीजिए। ओके, मैं आपको एरो से बता रहा हूं तो आपको जल्दी समझ में आ जाएगा। ओके, सो देयरफॉर हमें क्या मिलेगा कि देयरफॉर dw विल बी इक्वल टू p dv। ओके, ये मिल गया। अब हम इसे इंटीग्रेट करेंगे। अब इंटीग्रेशन में dw विल बी इक्वल टू, ओके, अब यहां पर हम प्रेशर कांस्टेंट रखने वाले हैं। ओके, हम लोग यहां पर एक्सटर्नल प्रेशर की बात करते हैं। एवरीवेयर प्लीज रिमेंबर इट्स द एक्सटर्नल प्रेशर। सो एक्सटर्नल प्रेशर इज कांस्टेंट, सो वी आर गोइंग टू कॉल इट एज dv दिस वे। ओके, इस तरीके से। लेकिन अगर हमने ये माना, ये कौन सा केस हम लोगों ने कंसीडर किया था कि अगर प्रेशर कांस्टेंट है तो, ओके, देन वी गेट दिस कांस्टेंट प्रेशर, तो हमें ये एक्सप्रेशन मिलेगा। लेकिन अगर हम लोगों ने ये कंसीडर किया कि प्रेशर कांस्टेंट नहीं है, ओके, क्योंकि हमें मैक्सिमम वर्क की तरफ जाना है, तो प्रेशर को हमें बदलना होगा, तो वॉल्यूम बदलेगा और इस तरीके से पिस्टन विल गो टुवर्ड्स अ ग्रेटर हाइट। तो हम क्या करेंगे फिर कि इसको ऐसे ही रहने देते हैं। ओके, dw is equal to pdv. You know the ideal gas equation very well. Yes, that ideal gas equation is for 1 mole of a gas is pv equal to RT. So therefore V will be equal to, or I'll just say P will be equal to RT upon V. तो ये अभी इधर सब्स्टिट्यूट कर दो, तो हमें क्या मिलेगा, dw is equal to RT dv upon V. ओके, ऐसा मिलेगा। ओके, आइडियल गैस इक्वेशन says PV is equal to RT, so P is equal to RT upon V. अब ये यहां पर सब्स्टिट्यूट कर दीजिए तो हमें मिलेगा dw is equal to RT dv upon V. ठीक है, R is the gas constant, नाम से ही पता चलता है, it's a constant. T is temperature. We are assuming the process is isothermal, so the temperature is also constant. So now when we integrate this, so what we get is integration of dw is equal to RT integration of dv by V. So that is equal to integration, you know, small portions all being brought together. So you get a larger portion, small amount of work done is going to be brought together. So we get a large amount of work done. So therefore what we get is a capital W is equal to RT log exponential V2 upon V1. These are the two limits, V1 and V2. और ये आप जानते हो अच्छी तरीके से, V1 मतलब it's the initial volume and V2 is the final volume. Correct? So this is by maths, simple maths, that integration of dx by x is nothing but is the exponential log of the final limit to the initial limit. ये शायद आपको मालूम होगा। ओके, नहीं मालूम है तो इंटीग्रेशन ये चैप्टर जो मैथ्स में है उससे आपको पता चल जाएगा। So W is equal to RT log exponential V2 upon V1. अब ये जो एक्सपोनेंशियल है उसका वैल्यू इज 2.303, तो अगर मुझे उसको log to the base 10 करना है, okay, whenever we do logarithmic calculations, it is always to the base 10. So therefore, I get a new expression, and therefore W is equal to 2.303 RT log to the base 10 V2 upon V1. Okay, this is for n is equal to 1 mole of gas. लेकिन for n moles of the gas कितना आएगा फिर? अगर ये 1 मोल के लिए तो n मोल्स के लिए कितना आएगा? बहुत कॉमन सेंस है, उतना n से उसको मल्टीप्लाई कर दीजिए। So it is log of 10 V2 upon V1. लेकिन क्योंकि we are talking about here expansion of the gas, और expansion में I've already explained you before that sign convention says very clearly that the work done is negative, and therefore the negative sign comes over here. So this is, my dear friends, the expression for work done. And which work? Maximum work. तो यहाँ पर मैं लिख देता हूँ W max. Okay, I write down as what? W max. Okay, or I got another one as well. Okay, एक और एक्सप्रेशन मुझे मिलेगा, कैसे? Okay, जैसे मैंने बोला है, ये वाला हम लोग ने कंसीडर नहीं किया था, this part. Okay, this part not to be considered. Okay, because we are going for maximum work, right? So इसलिए pressure can change. तो यही एक्सप्रेशन को जो वॉल्यूम के बेसिस पे है, I want to convert it in terms of pressure. Okay, और आप जानते हो अच्छी तरीके से दोस्तों, Okay, that volume and pressure are inversely proportional. So it's very easy now, my dear friends. If you have understood the one expression, the other expression becomes very easy. This is the way you need to learn chemistry. Alright, so if it is in terms of volume, if it is V2 upon V1, so what should come in terms of pressure? Come on, what should be? It should be P2 upon P1. If it is V2 upon V1, so should it be P2 upon P1? Or should it be P1 upon P2? Oh yes, you said it right. Because they are inversely proportional to each other. And therefore, we get a new expression. And that is W is equal to minus of 2.303 nRT log to the base 10 P1 upon P2. Okay, this is what we get. So if it is in terms of volume, then we say it is final volume upon initial volume. But if it is in terms of pressure, then we say it is initial pressure to the final pressure. So these are the expressions. Okay, this is what the entire derivation is. A quick recap now, and that is, right now we are discussing about derivation of maximum work. So let us consider a cylinder fitted with a movable piston. Capital A is the cross section of the cylinder, which is constant. F is the constant force, okay, which is going to be acting on the piston. We are assuming expansion of 1 mole of a gas. 1 mole is a small amount. So therefore, because of expansion, the piston will be lifted upwards. वो ऊपर की तरफ जाएगा, लेकिन जब वो ऊपर की तरफ जाएगा तो थोड़ा सा ही फासला तय करेगा, क्योंकि अमाउंट ऑफ द गैस मेरे पास कम है, तो वो जो थोड़ा सा फासला उसने जो तय किया है उसे हम लोग कंसीडर करेंगे एज व्हाट DL. फिर दो सिंपल फॉर्मूला है जो आप सब लोग जानते हो. वर्क इज फोर्स इनटू डिस्प्लेसमेंट, प्रेशर इज इक्वल टू फोर्स अपॉन एरिया. तो ये हम लोग ने कंसीडर किया हुआ है. तो देखिए फिर अगर प्रेशर इज इक्वल टू फोर्स अपॉन एरिया, तो फोर्स विल बी इक्वल टू प्रेशर इनटू एरिया. dW is equal to force into displacement. Force constant है तो work and displacement are directly proportional. Displacement कम है तो work is also less. So हमें ये मिलता है expression. Force is pressure into area, तो हम लोग ने इधर substitute कर दिया इसको. So dW is equal to pressure into area into dl. Area into dl. Okay, area into distance is volume. लेकिन क्योंकि area is constant, so distance and volume are directly proportional. And because the distance is small, so volume is small, so that means it is dV. So dV is equal to A dl. Alright, अब ये इधर सब्स्टिट्यूट कर दिया तो मुझे क्या मिला? dW is equal to PdV. Okay? अब यहाँ पर इंटीग्रेशन नहीं करना है हमें, बिकॉज प्रेशर को कांस्टेंट नहीं रखना है. हम जाएंगे यहाँ पर आइडियल गैस इक्वेशन, PV equal to RT for 1 mole of a gas. So P is equal to RT upon V. वो इधर सब्स्टिट्यूट कर दीजिए तो RT dV upon V हो गया. अब इसे इंटीग्रेट कीजिएगा. RT is constant, so it is outside, and then you integrate the volume with respect to the initial volume and the final volume. So the solution of this integration will give you log exponential of the final volume to the initial volume. Log exponential has to be converted into log to the base 10. Okay, because the calculation becomes easy. So you multiply by 2.303. So this is what you get. The negative sign indicates that expansion of gas is taking place. Okay, and volume and pressure are inversely proportional, so that's why we get, in terms of pressure, it's initial pressure upon final pressure. You getting me, everyone? Absolutely correct. The derivation is very, very clear. Oh yes.